guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is one rational expression. I will learn how to solve rational equations with one rational expression is our objective today. Now, in the handout, it says that in this scenario, the simplest strategy is to cross multiply. However, when we move on to the next lesson, which is called multiple rational expressions, cross multiplication is a strategy that will no longer work. So, in this case, I would like to teach you a strategy that will work on both lessons. That way, we don't have to remember, do I cross multiply here or whatever, right? So, we are going to use another or a different strategy. Let's start with our first example here. We are going to solve for x in our rational expression 4 over x minus 3 equals 7. So, in order for it to be the same, I would like to make sure the 7 also has a denominator. Okay, just like when we did our adding and subtracting rational expressions. Hopefully you watched that video before coming here. Adding and subtracting rational expressions. Okay, in those, we had to get the LCM, right? The least common multiple. And we're going to do something the same, but different in a way that I don't have to include the denominators towards the ending of my solution. So, Biz, what are you talking about? So I have here that this equation is equal to this equation, right? Or rational. But then, right now, they don't look like equal. Because this one has an x minus 3 in the bottom, and that one has a 1 at the bottom. So, they're not equal. So, our job is to make them equal. So, we're giving... So this one has an x minus 3, but this doesn't have an x minus 3. So I am going to give that an x minus 3 for it to be the same, right? And whenever I give to the bottom, I have to give it to the top, right? So I'm going to do that later. Now, this has an x minus 3. This has an x minus 3. Now they're equal. And then this one has a 1, but this one also has a 1. Right? But you don't really have to give 1, but just for the sake of solving and trying to understand, let's give it a 1. Although 1 doesn't really matter, right? Because x minus 3 times 1 will still be an x minus 3. So because I give the bottom 1, I'm going to give the top 1. Because I give the bottom an x minus 3, I'm going to give the top an x minus 3. Does that make sense? So now, it looks like their bottoms exactly match each other. And I don't have to worry about the bottom anymore because they are now equal to each other. In this case, I am just going to focus on the top. So on the top, I have 1 times 4 equals 7 times x minus 3. So I'm going to make them equal. I'm going to solve for x so that they're equal to each other. 1 times 4 is a 4. And I'm going to have to distribute the 7. So 7x minus 21. And I'm going to have to combine the numbers. So plus 21 on both sides. That will give us 25 equals 7x. Divide by 7. And we have x equals 25 over 7. Okay. Normally, we have to check our equations, right? We have to solve 25 over 7 and see if it actually matches. But because in this case, we already had to match it in the beginning, the denominator, so we know that that x is going to work. Now, here's our problem. We have something called this is a rational, right? A number over a number. And in those cases, we need to make sure that our bottom will not be ever 0. So let me go back to the original equation, which we should have done this one in the beginning. So this is my original equation, has a variable x in here. What would be a number or a value that x cannot have? Because when that specific value is inputted in there, if you plug that into the x, we're going to get 0. And that value is a positive 3. Because if I plug in a positive 3 in here, take a look, a 3 minus 3, that is going to be 4 divided by 0, and this is an error. So our domain restriction is that x can be anything, but it cannot be a 3 because it will make our whole entire equation be error, right? Or undefined. Now, for checking, you're just going to have to ask yourself one question. I have a domain restriction that x cannot be a 3. Is my x a 3? No, it's not. Therefore, 25 over 7 is our final solution. Now, what if my x value and my domain restriction matches each other? If it does, then we will say no real solution onto there. Okay? Moving on. I have here x plus 5 equals 4x. I think it's easier if we do our domain restriction first. Yeah, so let's do our domain restriction. My domain restriction my denominator has an x. And in order for us to solve it undefined, we need to make a domain restriction that x can be anything, but of course it cannot be equal to 1. Because the moment that x is equal to 1, the whole bottom will be a 0. All right then. So I'm going to solve x plus 5 over 3x minus 1 equals, instead of writing 9, I'm going to write it as a 3 times 3. You know why? Because I have to make sure that this bottom is equal to this bottom, right? And this one already has a 3, but the 9 also has a 3. So in order for us to see it, like what is missing in there, I'm going to write it as a 9 instead. Or I'm going to write it as a 3 times 3. So let's find out what is missing, because we need to make sure that the denominator on the left matches with the denominator on the right. First, this one has a 3, this one has a 3. But this has 2 3s, and this one only has 1. So I am going to give that 1 3. Okay? Now, moving on. Let's go to the other one. This has x minus 1, but this one doesn't have an x minus 1. So I am going to multiply that with an x minus 1. Okay, now that they match, I have a 3, I have a 3, I have a 3, I have a 3. I have an x minus 1, I have an x minus 1. So our denominators now matches. And remember, whatever you do to the bottom, you do to the top. Whatever you do to the bottom, you do to the top. And now, our denominators are equal to each other, so we can ignore them because they are already equal. And then our job is to make the left equation equal to the right equation. But since the bottoms are already equal, I don't have to worry about them. I am going to worry about my top equations though, because I need to make sure that they are equal to each other. Okay, so this is 3x plus 15. I have to distribute the 3, 4x minus 4. Okay, good. And then let's combine all the letters, all the one with variables. So minus 4x, and then let's do it one by one so we don't get confused. So this is negative x plus 15 equals negative 4. And now let us subtract 15 on both sides. And I'm going to have negative x equals negative 19. And then, of course, you have to divide x on both negative 1 on both sides. Here, x is equal to 19. Now, let's ask ourselves one question. My domain restriction is x cannot be 1. Is my x 1? No, it's not. So 19 is our final answer. There you go. Very quick, right? Moving on. Okay, so let us make sure that our bottom matches. So I have x plus 7 over x minus 2, x minus 3 equals 1/2. By the way, let's deal with our domain restriction first. X cannot be x minus 2. In order for that to be a 0, right, x cannot be a 2. Because if x is a 2, 2 minus 2 is a 0. That's a no-no. What about the other one? That x cannot be a positive 3. Okay. Now, let us make sure that our denominator matches. This has a 2, but this looks like it doesn't have a 2. So let's give it a 2. This has an x, wrong one. This has an x minus 2 and x minus 3, but this one doesn't. So let's give that x minus 2 and x minus 3. Okay, now let us see if it matches. I have a 2, I have a 2. I have an x minus 2, I have an x minus 2. I have an x minus 3, I have an x minus 3. So this matches. So that is gone. But we need to make sure that whatever we give to the bottom, we give it to the top. So let's give that to the top. And then let's write the top. We have 2x plus 7 equals, the 1 doesn't really matter, right? So we have 2x plus 14 equals, I have to FOIL this. This is x squared minus 3x minus 2x plus 6. 2x plus 14 equals x squared minus 5x plus 6. Now I have to combine. I have a quadratic, so I have to move. I have to move all of this. So minus 2x minus 2x minus 14 minus 14. So we are going to have, what do we have here? That's gone. We have x squared minus 7x minus 8 equals 0. And this time, we are going to factor it because we have a quadratic. So we're looking for two numbers that when we multiply, we'll get negative 8. When we add, we'll get negative 7. So looking for two numbers that when we multiply, or a factor of 8, that when we add them, we'll get negative 7. I think that's really, really easy, right? So that's minus 8 and plus 1. Because negative 8 times 1 is a negative 8. Negative 8 plus 7 is a negative 7. So we are going to solve it as x minus 8 equals 0. That's a positive 8. X plus 1 equals 0. That's a negative 1. Now, let's ask ourselves something. My domain restriction is that my x's cannot be a 2, cannot be a 3. My x's in the solution is an 8 and a negative 1. And so we're good to go. Our final answer is negative 1, comma, positive 8. Now, miss, what if this was a 3? And my domain restriction was also a 3. So you don't add that as your final answer. Right? You only have negative 1 is our solution. Okay, what if they both matches? Then you would say no real solution. Okay, I hope that this video will help you solve or learn you can do your assignments on your own. Thank you guys. If you have any questions, please let me know. And I hope that I will see you guys again on the next video. Bye.